Okay, our second lecture is a tropical curve or tropical curve with a conic section. In the previous chapter, I introduced what is a tropical addition and tropical multiplication. Based on this rule, we can plot the quadratic function of tropical or quadratic function. So for example, we know we can guess the shape of the quadratic curve. Okay. That is a quadratic function. And if we plot the graph, maybe the conic paraboloid like this. Okay. However, we live in a tropical world, so our rotation will change. A tropical sun. Okay, we live a tropical world, so addition will be changed. Should be changed the tropical sum, and the multiplication should be changed a tropical multiplication. We will plot the following graph. Okay, because as the previous chapter 1, as I mentioned, because the tropical sum satisfies associative law, we can first consider write this. This means that we choose maximum one tropical sum x and tropical multiplication means a natural usual addition, as you know. So that guys becomes like this. And this part we can say like this. Okay. Then we can plot the graph. First, we consider the first term. We can understand that is a function. Think about y is equal to 1 and y is equal to x. Then we maybe okay blue this okay, then the red is a constant function and blue guys is a linear function. And the intersection point is 1, but not that maximum function. So we can understand based on the line x is equal to 1, if x is less than 1, the maximum is here. Okay. However, based on y is equal, if x is greater than 1, then maximum function is the linear function. So if we plot max 1 or x will be plotted like this. Okay. So, what about these guys? If we plot this graph, that graph will be here. When you think about when you investigate it, two between intersection point of these two graphs, then the intersection point occurs at x2. So we can think about this here. The green graph to plot it here. So if this means that if x is greater or equal than 2, by definition of a maximum, the graph will be this green line. So finally, if we plot the graph, can see the following, we can obtain finally the following graph. Let's see now. That is here. And x is smaller than 1, that is y equal to 1. If x is between 1 and 2, linear function, that is here, and x is greater than 2, the graph with a green line, that's here. Okay. Here is, let's see, based on this graph, let's see some observation. Let's observe the graph. The remarkable point is that unlike a quadratic function, as we know, which means that a paraboloid, okay, there exists, as you know, that function is continuous function. Continuous, that is also continuous, but that is a differentiable, everywhere differentiable. Okay, there exists not differentiable point, so-called cusps. What is cusps? This part. Okay. Precisely at x1 and x2. In a tropical world, very fancily speaking, elegantly speaking, note that these points, that when you consider the blue, okay, blue function and red function, the cusp is both cusps of maximum of two functions, which means that in this point, in the blue one, max one, and the red point is also one. Okay, that means that is constant function, and that is the linear function. In this part, maximum x at 2 and minus 2 plus 1. In this case also, it's 2. So, this point, these cusps, are obtained this point maximum all obtained twice. Okay? That is a fancy expression of cusps on a tropical geometry, tropical curve.